Alright, welcome pre-calc students. This video will hopefully cover 48 all the way through the end of the final exam review packet. We'll see how quickly we can move. Alright, this says from a point 200 feet from its base. 200 feet from its base. What is the base? From a point 200 feet from the base, the angle of elevation from the ground to the top of a lighthouse. Alright, we've got the base of a lighthouse. And the top, the lights coming out. That is our lighthouse. From the base, 200 feet. Lighthouse. Okay, angle of elevation is 55 degrees. Right, so elevation is from the ground up. This is our angle of elevation. How tall is the lighthouse? Alright, your answer should be correct to 3 decimal places. So this is quite simple, actually. We've done this a lot, actually quite a long time ago. We're going to do opposite over adjacent in this case. So this would be our hypotenuse. We're saying this is our 90-degree angle. So the opposite over adjacent, we could say, right, so ka toa. So tangent of this angle, 55 degrees, is the opposite over the adjacent. So then we could multiply both sides by 200, and we will get what x is. Now it's important that our calculator is in degree mode because we are typing in a degree angle, so I have it in degree mode. If you need to change modes, you hit mode, go down here, hit enter. Alright, so we're going to type in 200 tangent of 55 degrees, enter. Alright, so our height is 285.6296. So the 296.6296. We look the third place. This 6 tells me it's going to increase. Well, the 9 isn't going to increase to 10, so that's really 30. And that would be rounded to 3 decimal places after the decimal point. Alright, and how tall is it? We're talking about feet, so the answer is the lighthouse. Is 285. Let me write that again. Alright, the lighthouse is 285.63 feet tall. Alright, so that'd be 48. 49. A truck is traveling down a mountain. A sign says that the degree of incline is 7 degrees. So we've got a truck traveling down. Okay, this is my truck. That's really goofy. Okay. Alright, that's a better truck. A truck is traveling down a mountain. A sign says the degree of incline is 7 degrees. So the incline is 7 degrees. After the truck has traveled 1 mile, so if we know that this is 7 degree of incline, if we put this line here and we do this, because of the parallel nature of these lines and it's cut by a transversal, these are alternate interior angles. So this is 7 degrees, so is this 7 degrees. After the truck has traveled 1 mile, so the length here is 1 mile, and it gives us the feet. So after the truck has traveled from here to here, which is 5,280 feet, how many feet in elevation has the truck fallen? So it sounds like we want to know this value. And if we make that into a triangle, we can see that, well, we know the angle is 7 degrees, opposite of our hypotenuse. We could also do the triangle this way. If you wanted, this is how much it's fallen. This is 5,280, and this is, what did I do wrong? 7. There we go. So you could do it that way as well. Either one will give you the same answer. So here we have opposite and hypotenuse. So we're going to go sine of 7 degrees is opposite over hypotenuse. Multiply by 5,280. and type that in. Make sure we're in degree mode. 5280 times sine of 7 degrees. And we have that we have fallen 643.470 feet. And that would be our answer. And it says correct at 3 decimal places, so make sure that you are rounding. All right, great, that's 49. Number 50, the owner of our garage shown below plans to install trim along the roof. The lengths required are in bold. How many feet of trim should be purchased? Your answer should be correct at 3 decimal places. All right, well, now I can drop a perpendicular here and make a 90-degree angle. That's going to help me out. If this is 20 and this is symmetrical, I know it's symmetrical because this angle and this angle are the same, so this side length and that side length are the same. So if I drop my perpendicular, this 20 feet is going to be cut in half. So if I look at just this one triangle, I have 10 feet, I've got a height, I've got 50 degrees, and I want to know this length right here. Now this is only half of my length. The other length I can just double, right? Because this and this are the same. Now I know they're the same because of the angle measures being the same. Okay, so this is adjacent over hypotenuse. So we're going to use cosine in this situation. Cosine of 50 degrees is 10 over x. So in this case, instead of multiplying by 10, we're going to multiply by x and then divide. So 10, my pen's giving me issues, x cosine of 50 degrees, divide both sides by cosine 50, and x equals, what's 10 divided by cosine 50? 10 divided cosine 50 degrees. And we get 15.557. 15.557. And here we're talking about feet. Now, what I just found was this length right here, 15.557. But if I want to find the total length of the roof, I would need to double that. Times 2, multiply times 2, times 2, and we get a total of how many feet of trim should be purchased? You should purchase 31.114 feet of trim. All right, that's a great real-life example. All right, so that was problem 50. We got 4 left, right? 51 to 54. Cool. So 51, an airplane. Aha. An airplane needs to take a detour around a group of thunderstorms as shown in the figure below. How much farther does the plane have to travel due to the detour? All right, so normally it would have traveled 50 miles. So we need to be careful about our answer because it says how much further. So we want to take our answer. Let's say we had to travel 60 miles. Well, how much further is that? Well, 10 miles. So we need to be careful that our answer is taking away and finding the difference because it says how much further does the plane have to travel. So that was just, I just threw that number in. Let's actually go and find it. So we need to find this value. Let's maybe call this, let's label this triangle A, B, C. And then we can label this side A and this side C. And we know side B is 50 miles. Okay? So we know angle, side angle. All right, now since we know there are 2 angles given, we can find this other angle. We can just find angle B by taking 180 and subtract the other 2. So find the sum of the 2, 54, and take 180 minus 54. And we get 126. So our angle B is 126 degrees. How is that helpful? Well, in order to use the law of sine, I need to know an angle and its opposite side. So I can go sine B over B, 126 over B, 50. This over this is equal to the sine of that over that. All right, so we can set up that proportion and work that out. And then for the other one, to find our side length C, we can set up the same proportion of sine of 126 degrees over 50 is equal to sine of angle C, 20 over C. All right, so you're going to do your cross multiply and divide. So 50 sine 20, 50 times sine of 20 degrees, multiply that, we would multiply that equals C times that. Then we're going to divide by the sine of 126. 126 equals C. And this is approximate, right? So we're going to find that. 50 sine 20, and parenthesis, be really careful, divide by sine of 126. All right, so our angle C, I'm sorry, we're not finding an angle. We are finding a side length. Side length C is approximately 21.138. And what are we talking about here? Miles? All right, C is approximately 21.138 miles. That's important. And then we want to do the same thing over here. 50 sine 34 divided by sine 126. Approximately A. So A is 50 sine of 34 degrees, close parenthesis, divided by sine of 126. All right, and we get 34. A is 34.560 miles. Okay, so all right. So now we need to figure out, well, what was the question even asking us? We want to know how much farther does the plane have to travel. It was going to have to travel 50 miles, and now in total it's going to have to travel 21.138 plus 34.560. So if we add those together, we get 55.698. And then we want to say, well, what's the difference? What's the difference between that and what it was going to have to travel anyways? Well, it was already going to travel 50 miles even. And if we subtract, we end up with 5.698 miles further. Okay? All right, it's important that you're putting units. It's important that you're reading the question. I think this further, how much further does the plane have to travel, that one can really get you caught up. All right, great. 3 more to go. Determine the area of that triangle. Oh, look at that, A, B, and angle C. So we just use our formula sheet, and we're like, here we go. I'm even given the area formula. The area is AB sine C. I'm sorry, 1/2 AB sine C. So 1/2 of A times B times the sine of angle C. And technically, I don't even need my calculator for this. 1/2 of 4 is 2. 2 times 10 is 20. And 20, what's sine of 30 degrees? 30 degrees, sine, cosine, sine. Sine is 1/2. This is 1/2. And 20 times 1/2 is 10. So we wouldn't want to say just 10. We would want to say 10 units squared. So technically, you don't need your calculator for that. You could, if you wanted, plug that in. But I think you guys got that. All right, so area is 10 units squared for number 52. All right, 53. Last 2 problems. A real estate appraiser wishes to find the value of the lot below. We want to determine the length of the third side of the lot. Okay, determine the length of the third side. So we've got 2 sides. We need the other side. We can't use the ratio and law of sine because we have this angle, but we don't have the side opposite that angle. So we need to use law of cosine. So I need to label these so I can talk about them. Let's say this is A, B, C. So if this is angle A, I want to find side A. This is angle C. I want to find, this is side C, and this is side B. All right. So it says determine the length of the third side of the lot. So this third side would be A. So to find A, if that's the thing I want to find, I'm going to set that out here. A squared equals B squared plus C squared. So I'm using my formula, but it's going to look a little different, right? Here, they're isolating C squared, but I already know what side C is, so I don't need to worry about that. I know the angle A, so I want that to be here, and I'm going to find side A. So if this is A and that's A, then this is B and C respectively. Okay, so I'm just using that formula, and minus 2 times B times C cosine of angle A. All right, so we're going to plug in what we know and solve for what we don't. B squared, we're going to take B, 250, and square it. We're going to add it to 160 and square that. Minus 2 times 250 times 160 times cosine of angle A, which is 62 degrees. So really, this is just a big calculator problem crunching numbers. I would encourage that you work this out. Be careful, this is a product. It's multiplied to cosine, so we can't just add this and that together. That's one thing that students are tempted to do. So we take 250, square it, and add 160 squared, and we end up with 88,100 minus, let's simplify that, 250 times 160 times 2, right? And this is a negative number, so minus 8,000 cosine of 62 degrees. Sorry, that looks like a square. 62 degrees equals A squared. So, basically we can plug this in. 88,100 minus 8,000 cosine of 62 degrees. And I'm putting in a degree measure. Make sure you're in degree mode. Enter. And we get a very large number. A squared is equal to 84,344.2275. And then we need to square root both sides. And that will give us our A. And this is an approximation. So second square root, the second answer, and we get 290. Does that make sense? Here's 250, here's 160. Yeah, 290 is in the ballpark. So 290.421, right? So be careful, is this degrees? Nope, it's feet. All right, we just found the third side length, and that was our answer for, uh-oh, hold on one second. Did I make an error? All right, I just found I made an error. Let me hit pause, find it, and I'll explain. All right, I'm not sure exactly what happened. It must be somewhere with the order of operations, but this right here, if I type this line above into my calculator very carefully, I will get something different. So let's type it in carefully. Okay. All right. Previously I was simplifying and I got a different answer, so let's not simplify. Just type it in exactly as we see. 250 squared plus 160 squared minus the quantity 2 times 250 times 160 times cosine of 62 degrees. We need to close that parenthesis and then close the parenthesis again for this whole thing, and then I get 50,550 which is what I was supposed to get. So, I'm not sure exactly what happened. I think it had something to do with the order of operations. So we end up with 50,542.275. Oh, we'll say 498, and then when we take the square root of that, so we're going to go second square root, second answer, enter, and we get approximately 224.816 feet. All right, so I guess I'm going to encourage you to actually type that whole thing in very carefully instead of simplifying the other way. I really honestly don't quite know what happened. All right, sorry. So we determined the third side of the lot. We need to find the area of the lot. In order to find the area, we need two sides, 1/2 times the two sides times sine of the other angle. So I would use 62. So sine of 62, that's angle A. So we want B and C right here. So B is 250 and C is 160. If we multiply that out, 0.5 times 250 times 160 times sine of 62 degrees. And we get an area of 17,658.952 square feet. Right, so our area is in square feet. And the last problem asks, an area is 43,560 square feet. If land is valued at that much per acre, what is the value of the lot? All right, so let's see. We have more than or less than an acre. This is an acre is 43,000 and we only have 17,000. So it's less than an acre. So our value is going to be less than 56,000. So we can set up a proportion. So this many square feet is valued at that. 43,560 feet squared is valued at $56,000. Right? That says per acre, and that's 1 acre, and that's 1 acre. All right. So we know the square footage and the value of 1 acre, and our square footage is 17,658.92, that same value number up there, and we want to put over x because we want to know our value. So this is to this as that is to that. We can do our cross multiply. Get this out of the way. All right. So we take our answer right here and multiply times 56,000 and then divide by 43,560. All right, our value is $22,702.05. So in this case, it says near a cent. We wouldn't round this to 3 decimal places. It wouldn't make sense. All right. Ha ha ha. It wouldn't make sense. Okay. What is the value of the lot? $22,702.05. All right. The very last one of this packet. If you have made it here, good job. We need to find the area of the quadrilateral below. Your answer should be correct to 3 places after the decimal point. So let's see. A quadrilateral is really made up of 2 triangles. So if we find this area of this blue triangle, and then we find the area of this green triangle, and then we just add the blue and green together, we will find the area of the total figure. So we can do the area of the blue triangle is 1/2, and it's B times C. Right? These are the 2 sides and the angle that's included, so we would just have 35 times 38. 35 times 38 times sine of 126. right? So we could be using our formula. I'm sorry I didn't pull that out. So 1/2 AB sine C, 1/2 AB sine C. Type that in, 0.5 times sine of 126, and we get 500, sorry, I need a pen, 537.996 is the area of the blue, right? And we're talking about, it doesn't give us units, so I'm just going to say square units. And then the area of our green, again, the included angle here is 72, so we're going to say sine of 72 degrees. And we have 1/2 of 50 times 58 is the area. So half of 50 is just 25, so 25 times 58 times sine of 72 is 1379.031, but really it should be a 2, right? Units squared. And if we want to find our total area, we're just going to take these two areas and add them up. Plus 537.996. Enter. Final answer. The area of the quadrilateral is 1917.028 units squared. All right, and that is your final exam review. If you have tried it with the videos first, I would strongly encourage you actually printing out another one and redoing them without any help. All right, I hope that was helpful, and good luck.